And in true John Gibby fashion, I have crawled out of my hole, and I'm here to make a video showcasing my next project. And of course, I happen to have a cold at this point. But I'm going to do my best to get in what I can. This is a little game that I'm working on for my final project in my game programming class called Mannequin Paladin. And well, there's this little guy, which I call a mannequin. I kind of loosely modeled it after, like, you know, those little tabletop art mannequins. So hopefully it looks like that. But yeah, where to begin? Okay, so jumping. I like the feel of the jumping. And I watched a GDC video, which I will link in the description, called Building a Better Jump. And that was really eye-opening to me because I didn't feel like the native physics engine of Unity created a feel of natural sort of responsive physics when it came to gravity and drag. So taking what I learned in that video, I really took it to heart, and when I was writing the script, I pretty much implemented drag and gravity myself. So the rigid body, of course, mass is 1. You can't set mass to 0, otherwise I would. But because of the way the Unity engine works, you just kind of gotta have it. If I went any further, you know, I would just be writing my own engine at that point, which doesn't really work that well for a short-term final project sort of thing. Anyway, so there's no drag. I mean, there's a little bit of angular drag, but that doesn't matter. The angular drag is rotation, and it's locked on the z-axis, so it can't rotate because you don't want it to. So no drag and no gravity. So what I'm doing is, in my little script, I'm going to get this booted up, and while Visual Studio boots up, slowest applications to boot up are always Microsoft applications. Have you ever noticed? Anyway, what was I going to say? Shit. Well, anyway, well, we'll see which one loads first. We'll see. Visual Studio seems to be frozen. But, yeah, when I went to go actually script it, I have a method to handle gravity, and I have a method to actually handle drag or friction. Every collider in the scene has a physics material that sets it entirely frictionless. So there's no friction in the scene whatsoever. If there was, when the player, you know what, I'm gonna be able to show that right now. If, say, well, I've got the tile map here, and the tile map has all of these colliders that I've manually added onto it, and some of them don't have the physics material. So what's that one? So yeah, say I have got this. If I run the game and get, I can't get around that guy. This is sort of a placeholder NPC that I just put there to test if I was detecting hits. Anyway, this is the platform that doesn't have yeah, it's not going to work that easily. First of all, let's go to the player and let's remove, which one? I'm not using the caps collider, I am using the box collider. So if I remove the frictionless marker, and then I come to the tile map, and I go to this box collider, and I remove frictionless on that, what we're going to see is it's going to behave very differently. Well, first of all, as you can see, this is what I'm talking about. If there's any friction at all, say if I'm holding an input, if I'm going left and I jump, then you stick to the wall. And I guess I can remedy that by adding mass to my player, but that's not something I really wanted to do, because I don't know, it was easier for me to manually program all of these different things myself and have the player script manually handle all of these calculations than it would have been for me to find all of these perfect values for mass and linear drag and all of that. So I'm going to reattach the physics material because I really need to. Where did I have my frictionless? Yeah. So re-add frictionless to that. Frictionless there, and while I'm at it, I'll add a frictionless to the others as well. So no friction. That means that you're going to end up getting, you're just going to slide like it's ice, okay? And if I wanted to implement some sort of like ice thing, I probably would want to change up the system. But in the scope of this game, I hadn't considered like ice or sliding. So either way, I could probably have some sort of a trigger, and upon entering that trigger, it'll change the values in the script. So what I mean is, we're running on a fixed update, okay? Now, there are these animator values that I kind of, let's just not worry about those. Let's get rid of that and that. So now all we have is the inputs, or handling the player inputs, and then everything that goes with that. So at the beginning of each fixed update, we're going to check if the player is touching the ground. And for this method, I watched a video on creating a 2D platformer in Unity, and I will be linking that in the description as well. It was very helpful. What this guy did is he added points to the player, empty. So GPR, GPM, and GPL. That's ground point right, ground point middle, and ground point left. If we zoom in on the player here, GPR is on the right, GPM is in the middle, and well, that's wrong. I mixed that up. I mean, no matter. It's no big deal. I'll just fix that. And by that I mean I'm just going to rename them. Yeah, so the ground point right, ground point left, and ground point middle. Go back here. Ground point right. Let's do middle and middle. and left. There, that's better. So what the ground points do is, if we open this back up, first of all, you're going to run the overlap circle all method, and that's going to my understanding, it's going to act sort of like a trigger collider, in that it will detect other colliders that are within that circle, the set bounds. And for this method, you have a point of some sort. It's a transform component. It's a, well, rather, sorry, it's a vector 2. It should be a vector 2 somewhere in space, followed by the radius, and then a layer mask of what you're looking for, what colliders you want to collide with. Then what you're going to do is iterate through those colliders. As I've commented, this was a new thing to me, so of course I was just commenting it myself. So iterate through the colliders, and as long as the collider that you've reached isn't the player object, or the parent game object, which is the player in this case, then what you're going to do is return true. Yeah. And you know, if that doesn't work, and you know, we're also checking the velocity beforehand. If the velocity of the player is less than 0 or equal to, whereas if it is falling, that doesn't seem right to me. Less than or equal to. I think that should just be less than. But, I mean, it still works functionally, so that's fine. Anyway, I digress. Checking if the velocity is negative, and what that's going to do is, if you are falling, then you don't even check these, and you just return false. It's simple as that. If you're still falling, you're not grounded. So that's how I'm checking the gravity. And after I check the gravity, you get those inputs, and then you handle movement using, or you're passing into this method the horizontal axis and the jump axis. So this is the handle movement. You take in the float for X input and jump input, and then you create your direction. And there's two separate things that are happening here. First of all, this is going to handle if you're jumping. So what's happening here is you're checking if you're grounded and if the player is providing jump input. And if that's true, then you're going to set grounded to false, and then you're going to add force in the y-axis upward. So say that happens on that fixed update frame. Before it updates again, we're also going to check the x input. X input. We have a maximum velocity that we have preset, so as long as it's not less than negative max vel or greater than max vel, then you're going to be able to add force. And when it does that, it just takes the direction multiplied by the speed modifier. So those two things, it's going to do both of those each frame. They'll both happen at the same time to the player, so it works. Then we move on to synth gravity. This is the method that I'm using to synthesize gravity. So if the y velocity of the player is greater than 0, you're going to add just plain gravity. Okay, if your velocity is less than 0, however, you're going to add force of the gravity times a gravity modifier. And this is where the GDC talk comes in. And the man giving this presentation talked about Super Mario Bros. When the developers increased the force of gravity when Mario reaches his peak. So when he starts to fall, he falls faster. So the force of gravity is stronger when he's falling than when he's still in the air jumping upward. And using that, that's how they gave Mario his sense of weight and solidness. So that's why I've elected to do this. Otherwise, personally, I think that in 2D games, the character at that point will feel floaty, which is never good. Floaty kind of feels unresponsive. So after we synthesize the gravity, we're also going to need to implement our own linear drag. The problem with the linear drag that's built into Unity is it's drag in all axes. It's both vertical and horizontal. Now, what I'm using linear drag for is I'm trying to just implement friction with the ground with no vertical effect. So that's exactly what I'm doing. Pretty much at any given point, there is always a counter force to the player's movement that is half of the current velocity. So pretty much whenever the player's moving, if their velocity is greater than 0, it's going to be reduced, or sorry, there's going to be force added to it that's half as strong as the current velocity. So that's how you're decreasing in speed when you're walking, running, even in the air. It's at any point. There's always that counter force in the x direction and only the x direction. Okay, so let's go back up. Handle movement. So then we have attack. So we're also getting the axis for fire 1, which is the left mouse click. By default, at least, you can remap them. But if attack is greater than 0, we're going to move to handle attack. And for handle attack, I did the same thing as checking ground. The same exact thing. But instead of using ground points, I put points at the position of the sword. And what that's going to do is it's going to essentially act like a hitbox. And it's going to do the same thing. It's going to draw a circle. Ignore the debug statement. That doesn't matter. But it's going to get all the colliders, and then it's going to go through them. And if it's an enemy, what is mob? Rather, what is a mobile mob? If it's a mob, then it's going to debug hit enemy or did not hit an enemy. I'm currently not doing anything with this method as of yet. That being said, if we go back into Unity and we look at the Mannequin Paladin guy, we have HBPI, so that's hitbox point in and hitbox point out. So I just realized that the problem with this is I have these 2 points that are only going to be on this side. So I'm going to move that over because we're going to need to see it. That is a phone call, but I don't care. So as you can see, with the debug, we're drawing lines, and if I just deselect that, so those points are the center and then the radius. And I just put those to make sure that it was about the right size. So when they come around, you know, you've got these two circles. That'll be about quite wide, actually. So you've got those, but if you move over to the left side, those hit points are still on the left. So I'm going to need to programmatically modify them so that they'll flip when the player flips. Otherwise, that's just flat out not going to work. But I mean, making this video, this is essentially rubber duck debugging, so it's the same thing as me explaining my code to a rubber duck, which is a thing. I'm not crazy, but you debug that way and you find these issues that you didn't know that you had before. So that's what I've got so far. I'm just going to undo everything that I've changed. There we go. So yeah, the animators kind of aren't my big concern here, but I'll also get into those later in a later video. But this has been the introduction to the physics side of the Mannequin Paladin project. As I said, the GDC talk is going to be in the description. The 2D platform tutorial that I was following for the ground detection is going to be in the description as well. And also the GitHub repository for the project is also going to be in the description, so that you can go in at any time, you can view my progress, you can play with it yourself, you can see what I did, look at my code, and learn from it. Also, I'm going to put my Discord link in the description as well. If you want to come by the Recursive Roost, as the server is called. We have multiple programmers that are there. We'd definitely be able to help you out with programming. If you want to get into programming, one of our users has a Java teaching thing that he's doing. He's putting out videos to teach beginner programming as well. But yeah, stop by the server. We've got games, memes, media, videos, games. I always said that. Again, don't blame me. I've got a cold. I have an excuse for being loopy. But, I mean, it's also a great resource. It's a small community, and everybody's willing to help everybody. And maybe sometime in the future, we'll start a community project. I was hoping to get something started with Unity and kind of create this network of people that could just create a game in our community and just kind of have something to call our own, and kind of do that every now and then, so that people can get into it. They have resources to help. They can have people to ask questions with and all of that stuff. So yeah, check out all of that stuff. They're great resources, especially the 2D platform tutorial. And yeah, there you have it.